my name is Rachel Pipkin, and this is my lesson for Math 1351, and it is proportions for the 6th grade. The previous knowledge that each student needs to have is students must have a basic knowledge of multiplication and division. The lesson objective is based off of the TEKS 6.4G. The student applies mathematical processes, standards to develop an understanding of proportional relationships in problem situations and generate equivalent forms of fractions, decimals, percents, and using real world problems and using ratios. So, good afternoon, class. How's everyone after lunch? I know y'all are probably really tired, but I want you to pay attention and get excited because we're going to learn about a really cool concept today about ratios. So, are y'all ready to learn a bit of math today? So today we're going to learn about proportions and ratios. And by the end of the day, you're going to be able to tell me all sorts of crazy stuff about ratios and proportions. So, I know it might sound a little hard, but if you know how to multiply and divide, you can find proportions as well as ratios. So we'll start off with a quick review of multiplication and division problems. If I asked you how much 12 times 4 is, you would say 48. If I asked you how many times 25 would go into 150, you would say 6 times. And if I asked you how much 20 times 5 is, you would say 100. And if I asked you how many times 4 divided into that 100, you would say 25. See, you got this. It's going to be a breeze. So, when you are finding ratios, you either find a part to part or a part to a whole. So let's start off with working with objects before we jump into using numbers. First, there are 3 different ways to write a proportion, or a ratio, Either x to y, x colon y, or x over y. So what is a ratio? A student would say a comparison of either a part to a part, or a part to a whole. That's correct. So let's start off with a part to part ratio with objects. If I have 3 circles, 4 squares, and 1 triangle, and I asked you to compare circles to triangles, you would say it's a 3-to-1 ratio because there's 3 circles and 1 triangle. So that's one part of the problem and another part. So you would write it 3-to-1. Like that. Now, if I asked you for every 4 squared, that's a part-to-part ratio. Now, if I asked you for every 4 squares there are to how many total shapes, you'd first need to find the total number of shapes, which is 8, if we count them up. 1, 2, 3, 4, 5, 6, 7, 8. So, now if we wrote 4 over 8, it looks like a fraction, right? So what do we know about fractions that can be broken down more? It means that they can be reduced. So, if we reduce 4/8 to what? By 4, 1, 2. So, be 1 to 2. So that's right. Always remember when you're comparing ratios that you need to make sure you're comparing the same parts to each other. Okay. So, if I told you that there were 30 girls to every 25 boys in the school, how many boys are there compared to the girls? Students would say 30 to 25. And so we could write this 30 over 25. So can we simplify this ratio? Yes. And so what can we simplify this by? We can simplify this by the number 5. So, because 5 goes into both 30 and 25. So 5 divided by 5. And so what is 30? What is 30 divided by 5? 6. Ah, 6. That's right. And what's 25 divided by 5? 5. So your new ratio is 6 over 5, or 6 to 5, or 6 colon 5. Those are the 3 ways you can write each ratio. Okay, so let's kind of work with a percentage. Let's say Grandma came over for dinner, and she gave you, your sister, and your brother money. After dinner, you all get together and see how much money you got. You got $5, your sister got $2, and your brother got $3. If you wanted to see the percent of the total amount of money your brother received, you would first set up what kind of proportion. The student would say it would be a part to whole because you're comparing your brother's part of your money to all of the money combined. That's right. So how would you write your ratio? We would write it 3 to 10 because we have a total of $10. So if you wanted to find how much percentage of this amount, how would you set up your equation? Well, you know that the total of a percent is 100, correct? Right. So that goes on the bottom. And we want to find the percent, but we don't know it. So we would put in our variable x on top. We compare it to, and we would write our ratio as 3 over 10. Just like this. Now, when you're trying to solve for x, you need to use the cross multiply and divide method. So, you go, what's across from your x, which is 3, and you multiply to 100, and that would give you 300, and then you divide by 10, and this would give you 30. So your brother got 30% of the money that your grandmother gave all of y'all. Or gave all of y'all at dinner. Okay. So let's say let's work out another proportion. Or ratio, I'm sorry. Let's say that you're going to the game room at Mr. Getty's and you want to play the games, but all the machines only take quarters. You have $12 total, but they're all in dollar bills. So, how many quarters would you get for $12? Well, first let's set up your ratio. How many quarters are in $1? 4. That's correct. $1 equals 4 quarters. So what would your ratio for quarters to dollars be? It would be 4 to 1. So if I set up my ratio 4 over 1, and I want to see how many quarters I can get, I would do 12 over x. What would I get? Well, if you use the cross multiply and divide method, 12 times 1, 12 times 1 equals 12, and 12 divided by 4 equals 3. Now that seems a little off, because you have to have 4 quarters to make up $1. 3 is not even a whole dollar's worth. So, what did I do wrong? Well, I set up my proportion wrong. See, when you're doing ratios, or proportions, both, you're doing ratios or proportions, you need to make sure that you always are comparing similar things. So if I have 4 quarters for every $1, and I'm trying to figure out how many total quarters I'd have, I need to put, or how many total quarters would be in $12, I need to put X over my total, which is 12. So, so we'll go back and we'll do the cross multiply and divide again. So 4 times 12 is 4 times 12 equals 48 divided by 1 equals 48. So 48 quarters is how many you would have to spin a mystery X. Okay, so this is our last problem before we do our activity. So let's say you earn money washing cars, and you put 20% away in savings, and you kept $30 for yourself just to spend. So how much total money did you earn? Well, you know that 20 would go over 100 because you're doing a part to whole ratio. So 20 over 100, but you don't know your total amount, which goes on bottom, so that would be X, but you do know 30. But that's not quite right either, because you're looking for the total amount that you would get, and so that wouldn't, since 20% is only a part that you put away, you want to know how much you earned totally. So what's 100 minus 20? 80, right? So you put 80 over 100 equals 30 over X. So how much did we earn? How much did you earn total for washing a car? You would do 100 times 30 to give you 3,000, and then 3,000 divided by 80 equals 37.5, which equals a grand total of $37.50 that you made total for washing cars. So the rest of my lesson would consist of an activity sheet for each student that would ask some simple questions about ratios, and I would have each of the students identify first if it was a part-to-part ratio or a part-to-whole ratio, and then I would have them write out the ratio in the different forms, either the x to y, the x colon y, or the x over y, and then have them also reduce it to the simplest form. And then finally we would end our lesson with talking about how to turn ratios that we already know into percents we don't know. And so that's the end of my lesson. Thanks.